This is a class called person, and I'm using strings from the standard library to build a very rudimentary model of a person. They have a first name, a last name, some kind of number, might be an employee number or some other kind of identifier, and an expensive resource that I wish to manage the lifetime of. Let me just show you the header file for resource. You can see that this doesn't actually wrap up anything expensive like an open file or a database connection or a huge piece of memory, but it pretends to, right? We're going to manage it as though it contained something that we really needed to manage. I have a constructor for resource and a copy constructor to make one resource from another, and a copy assignment operator to set the values of one resource that already exists using another, and I have a destructor. You might imagine that if there really was an expensive resource in here, that the destructor, for example, would clean up that resource. And when you implemented these copy constructor and copy assignment operator, that they would do a deep copy where they'd make a new resource and get the values over. In fact, all that I do in resource is just squawk. So when you construct one, I print out that you're constructing one and I echo out that string, the name. When you copy construct one, I set the name and then just say that I'm doing one. Now, when you do an operator equals, the values are going into an object that exists already. And so you need to clean out what it has, delete things if it holds pointers, close things if it has open things, and then put the new values in. In the case where somebody assigns a value to itself, they write x equals x. If your copy assignment operator cheerfully clears everything away to get set for the new values and then copies the new values over, the new values have been cleared away because you were assigning to yourself. So if I had real resources, I would check for self-assignment, and in the absence of self-assignment, clean up the existing resources and then set their new values. All I do here is set the value of name, which, because it's a string, it's not any kind of a pointer. It's like setting a new value to an integer. And then I squawk that I am doing a copy assignment operator. And one of the tricks with a copy assignment operator is that it actually returns something, and you return the contents of yourself. And that's so that people can chain x equals y equals some value. And the value will end up in both of them because they return their new value. Finally, the destructor of resource just squawks that it's destructing. So person has resource as a solid member variable. And when we construct a person, we have a constructor that doesn't take a resource. And then we have this set resource function and a get resource name function that goes into resource and asks it for one of its member variables. But it's a solid member variable. How can you create one when you first construct a person if you don't put anything to it? This really relies on a sort of signal value, that there's some appropriate default that you can use. And there may not be an appropriate default for the thing you're thinking of doing, in which case you'll be moving on to a technique I'll show you a little later in this demo. But if you can, let's take a look at the constructor for person. We just initialize that resource, that person's resource, with quote, quote. And the constructor for resource takes a string, so we'll initialize it with an empty string, and we'll have a resource. It'll be kind of an empty or useless resource, but we'll have one. So then I have some code to exercise this system. I'm going to make a person. That's going to make an empty resource with a quote, quote string. And then when set resource is called, let's go into that code. I'm going to make a new resource in local scope with that string. It's going to use my copy assignment operator, which is just going to say, this one's name equals that one's name. And if there were more fields, it would do it to more fields and copy everything in that resource over. Remember, resource is supposed to be big and expensive. So this is wasteful behavior. But it does work. And, working is a feature. Let's run it so that you can see what happens and the lifetime of this resource object as we go through. So at the moment, there's no output. We haven't done anything yet. And as we step over here, it squawks out that it's constructing the quotes. That's why you don't see anything after it. Then when we call set resource, it constructs that Kate resource on the local stack inside set resource. It copy assigns that into the member variable, and then it destructs the local one as we exit out of the set resource function. So if resources were in fact big and expensive, you can see that making one just to delete it is certainly wasteful. If we then immediately set the resource again to a different value, the same thing happens. So we construct that second resource, copy assign it, and then destruct it. You could ask what happened to the old one. It's a bit like asking what happens to an old integer. You know, when you say int I equals 3, then you say I equals 4, what happens to the 3? You know, there's just new values in those variables now. But now we're going to construct a new person. And this is, despite the presence of an equal sign on the line, this is a call to the copy constructor, right? We're constructing a person out of thin air using the values that are in this existing person object to initialize it. So when we step over that, what you see is that we copy assigned the resource, and then we're just copy constructing that second resource. The next line, we're going to do assignment. So now we have a valid and existing object, and we're going to override all of its values with the values from this existing object. So if we step over that, you can see that all we did was copy assign that second resource. We have an arbitrary call just to prove that we can still call things like get resource name, and you can see the values there. But what's interesting is what happens if we step over this return line. Big set of destructing. All of the resources that we constructed have been destructed for us automatically. When we come over this return, both Kate and Kate2 went out of scope, so their member variables came out of scope, so their resources got destructed and their destructors squawked. There's no memory leak in here. There's no call to new, so of course there's no call to delete. In many cases, this is really all that you need to do. Now, I deliberately set up an example that doesn't work that way because this idea that, well, when I first created the person, I don't know what I wanted their resource to be. I wanted to set it later. And those are the circumstances under which people tend to want to go with a pointer. The nice thing about a pointer, it can start out as null or null pointer if you want to use the C++11 feature, which is type safe. And then when someone calls set resource, we can create it out on the free store with new. But okay, let's stop right there. If we were to new up a resource out on the heap, what do you want to have happen when this line executes? Do you want the two person objects to both have a pointer to the same resource? Or do you want to make a copy of the resource so that they each have their own independent resource? There's no getting around that decision, and honestly, moving to smart pointers changes nothing. You had to make that decision when you were working with raw pointers. But now, having made the decision, we have a mechanism to express the decision and to write less code in order to express that decision. Now, person's a fake class. It has no business meaning, and resource has even less business meaning. So I can't possibly rely on my business knowledge of the circumstance to tell you whether two people should share the resource or should each have their own independent resource. Let's say, for the sake of argument, that I want them to be different. That's usually the case. So I need to set the wheels in motion so that when I copy construct or copy assign between person objects, that I make a deep copy. I actually create a new resource for the new object. I don't want to have to write all the code to manage these lifetimes and to remember to call delete, but I still have to accept the fact that I want a deep copy rather than a shallow copy. So let's go into person.h and we're going to change this from a solid object to a pointer, but not a raw pointer. I'm not going to say resource star like this. I want to wrap it up in a unique pointer. Now, I've already included memory, which is the header that gives you unique pointer. So I can do this. I want a standard unique pointer of resources, and I'll just change the meaning now of p-resource from person's resource to pointer to resource, and that way I can keep my name the same. Of course, that means that a place like this that was calling a member function, I need to switch to using this notation. And you notice I get good IntelliSense. Everybody is aware that it's a unique pointer to a resource, and it'll pop up resources methods when I use the points to notation. Now that frees us from having to initialize our pointer to anything. That's the whole point, right? We're moving off because it's optional and it's expensive to create a blank one. We don't want to go there, so let's not go there. When you create a person without passing in a resource, you don't get a resource. But this code for set resource is not right. Obviously, I can't allocate something locally and then somehow try to put a pointer to that into my smart pointer. I'm going to need to call new to get some memory out on the free store. So this goes away completely. And what I'm going to do here is I'm going to call a method called reset of the unique pointer, which resets its value from the null that it started out with to something else. And in this case, it's going to be a new resource object out on the free store. I need to pass something obviously to its constructor, and what I have is this resource name. I want to build this right now to show you the weird error messages that you get. The first time this happens to you, you're going to be confused. Cannot access private member declared in something I didn't declare. You didn't write unique pointer. So why are you somehow trying to access something that's private in it? And if you double click the error, it brings you to here. It doesn't even look like you're accessing any member variables. The first time this happens to you, if nobody's going to sort of take you by the hand and show you about it, you can lose an awful lot of time. The problem is not anywhere in the person class. And I can prove that. Go to the person.cpp, and on the build menu, if we just choose compile, build succeeded. Lickety split too. There's nothing wrong in person.cpp or in person.h. There's a problem in some other code that includes person.h. And that's causing the compiler to yell at you where the error appears to be in person.h. Let's go up to manage memory and look at these lines that are copying person objects around. Remember, person has no copy constructor, no copy assignment operator. The compiler generates them for you by default, and they copy the elements of the person object, including the unique pointer that you're not allowed to copy. If I comment out these two lines and build succeeded. The problem is not in the code you wrote for person. In a way, the problem is in the code you didn't write for person. Now, there are two ways to deal with this. One approach is to say, you know what? Person is not a copyable item. I don't want people making copies of person objects. I have a unique pointer in here. Don't copy. Okay. In that case, I can go in here where it's private, and I can declare the copy constructor and the copy assignment operator to be private. I don't need to implement them. No one's allowed to call them. If I now go back into manage memory and uncomment these 2 lines and build, oh, I'm going to get errors. I'm going to get errors, but they're better errors, right? Because now they say, hey, what are you doing? You're trying to use a private copy constructor or a private copy assignment operator over in person, and those are private. And so if I'm writing a random application and I try to copy people around and I get an error message telling me I'm not allowed to copy people around, and I go look in here and I see that these are private, I get that I'm not allowed to copy people around. And that's just a whole lot better than that error about a private member variable in standard unique pointer. It's about being expressive. It's about telling people what you want. But let's say that in fact, we want to be able to copy people. We just want a deep copy. So we'll make a fresh resource initialized with the values of the old resource. And then each of the 2 person objects will have their own resource that they can carry on with and change and work with as they need to. Well, in that case, I'm going to need to implement these 2 functions. So let's move them down into the public section and we'll write them. Start by copying my constructor that I already have. And then we'll just use these initializer expressions that are already here, saying initialize the first name from the other person's first name, the last name from the other person's last name, and the arbitrary number from the other person's arbitrary number. Just fix these up to be the member variables rather than the parameters that aren't there anymore. And then we'll copy this one to use as the operator equals. So an operator equals returns a reference. And we have to come at it this way. It's all pretty mechanical. But what about the resource? When we were constructing, we didn't do anything with the resource, and now here, when we're operator equaling, we don't do anything in the resource. We need to fix that up. Oh, the operator equal also needs to return its own contents. So the line I need is down here. I need to get the unique pointer pointing to something on the free store that's a brand new resource using the value of the old resource. I don't have this parameter resource name, but I do have another object I can copy from, so I can just use p get resource name. And that very same line will work right here. When you're constructing a brand new person from a person that already existed, you're going to make a new resource and put that into the unique pointer. Normally, when you're doing an operator equals, you need to clear away the old. The nice thing about the reset, because it's a unique pointer, if that unique pointer is actually pointing to something that was allocated for you out on the free store, when you call reset, it will clear it away. And I'll prove it. We've got squawks in the destructors, right? You'll see it. So it will make me a new one using this value, get resource name, and it will clear away the old one. It even does them in the right order so that you don't have to worry about self-assignment. So let's confirm this will now happily build. Build succeeded. And we'll just step through the exact same code and watch what happens in the output. So when we step over this line, we no longer have that constructing a blank one. That's good. When we call set resource, we just have the single constructing. We're not constructing the temporary, copying it, and then destructing the temporary. So we've had a big improvement if there really was an expensive object to create and delete. When we reset the resource, no, actually you're pointing over to second resource now. You see, the order matters. First, it constructed the new one, put it into the pointer, and then it cleaned away the old one. It's smart. It's done for you. This saves you not only from issues with self-assignment, but also if the constructor throws an exception, it doesn't destruct the old one, so the unique pointer is still valid. It's a very clever trick. Now, if that matters to you, if it's really important that your reset would delete the old one before it created the new one, just call reset with no parameters. That puts you back to being a null pointer, the unique pointer, and clears up whatever it was holding. And then call reset with the pointer. If that's better for you, you take control, you do it your way. So now we'll step over the assignment from one person to another. And you can see that we made another copy of second resource for the other Kate. We assign back. And again, we made a copy and destructed. Now they happen to have the same value, but they are different instances. And when we step over the return, both of the resources are neatly cleaned up. We have nowhere that we go around deleting resources. It's done for us automatically because the person went out of scope. When the person went out of scope, all of its member variables went out of scope. The member variable is a unique pointer, so when it goes out of scope, it calls delete on the memory on the free store, and there's no memory leak. Now, this wasn't that awful, right? Really, it wasn't. But you did have to write the copy constructor and the copy assignment operator for person. And maybe you don't want to do that. The code that I've written here, which is really arbitrary, really never does anything with the resources once it has them. And that might be the case in your application as well. It might not be each bank account having a log of all of its transactions. They should obviously be independent. But it might be more of a case where it's actually all right if I make a copy of the object for the copy to share access to the original. If that is the case, then you could use a shared pointer instead of a unique pointer. So if I go into person, and I'll just copy out that line and change this one to shared. This eliminates any need for my copy constructor and my copy assignment operator. So I'm just going to take them away. Now remember, in the constructor, we're still not setting it. So we have to have our set resource. And instead of reset, I'm going to use make shared. I want to make a shared pointer to a resource. And I pass in not a new resource. The whole point about make shared is it calls new for you. Just pass in the arguments that you want given to the constructor, which in this case is the resource name. Make shared is more efficient than creating the pointer yourself with new and giving it to the constructor of the shared pointer, because it saves an indirection as the pointer is being used. Let's build this. Now the build succeeded. And if I run it, when we step over this line, still no output because we don't create a resource anymore when we construct a person. Set the resource, single construction of it, excellent. Set the resource again. As before, we're cleaning up the old one. because the last object that was using it isn't using it anymore, constructing the new one. Now when we copy the people around, here we're constructing Kate2 from fresh, using the values in Kate. Nothing, no output. We didn't need to make any new resource objects or clean up any old ones. When we use the assignment, no output. If you can genuinely share the resources and they're expensive to construct, you can see right away how this is a performance improvement for your application. Especially when you think about the first version where we were making local variables on local scope and then copying them around. We've made them way more efficient. And then when we go out of scope, we just destruct the one because we only ever created one that they were sharing. And in terms of code, when you use a shared pointer, you don't have to write the copy constructor and the copy assignment operator. When you use a unique pointer, you do, and if you were being old school and using a raw pointer, you would also have to write the copy constructor and the copy assignment operator, and they'd be a lot more work. You'd have to do things like making sure you weren't deleting yourself. It's up to you how you decide on your lifetime, whether it is owned exclusively by this person object or whether it can be shared by multiple person objects. Whichever choice you make, you're going to express that very clearly in your code, and much of the code of implementing that decision is written for you, so that's a win. You get code that makes more sense to people who are reading it and code that was easier for you to write it. That's why smart developers use smart pointers. But don't forget, when we had a solid member variable, it was just a resource. We also didn't write very much code. As long as resource is cheap to copy around, that's the really easy way to do things. And again, you have expressivity and easy to read code.